Optimizing Ethereum Gas, Maximizing Efficiency. Module 1, Video 8. In Ethereum, gas optimization is important as it reduces costs as well as boosts efficiency. This video explores techniques to minimize gas usage while executing transactions and smart contracts. To understand how gas costs are determined, not to be confused with gas prices, first is the complexity of the transaction. More operations and storage needs increases costs, though these are fixed per operation. Second is resources. Gas compensates miners for using computation resources to process transactions. We need to optimize smart contract code to remove unnecessary operations, code paths, and repetitions to minimize gas usage. Optimize loops such that there are no unnecessary iterations and storage reads or writes. And we need to use efficient gas optimized libraries to handle common operations. Here we can see that a smart contract computes logic and pulls trusted data from Web3 API like oracles, which you will learn about in further modules, and then displays it to the client. These computations will cost gas. Now, some ways to minimize storage operations include using call data. It is a non-modifiable and non-persistent area which holds external data. We need to minimize on-chain data as more data stored means more gas fee. We should try to pack data variables to minimize memory slots wherever possible using struct. We should also use efficient data structures, like mapping helps us to store key value pairs. We should avoid arrays as they require more operations. Using struct to optimize storage slot packing to reduce redundant data storage. We should leverage off-chain computation using cloud computing, which is performing complex calculations off-chains and recording the results on-chain. We can also use layer 2 solutions which compute data off-chains and drastically reduces gas fee. You can also utilize Ethereum nodes for off-chain data retrieval and computation as well. You can also study more in depth about off-chain computation on your end. Optimizing storage layout. Packing variables pack related variables into the same storage slot. Variable ordering. Order variables from smallest to largest data type. Inheritance layout. Positions parent contract variables first in storage. Now, each EVM operation code has an associated fixed gas cost. We should always try our best to reuse intermediate arithmetic operation results. And as we know, efficient memory management can significantly reduce gas costs. Some gas optimized libraries are OpenZeppelin for smart contract development, mainly used for writing secure and scalable smart contracts. Aux library focuses on DeFi protocols and DEX contracts. Genesis library can be used for multi-signature wallets and safe contracts. To analyze gas costs, we can use gas profilers like Remix IDE Profiler, gas estimators, and also monitor gas usage during live execution for optimization insights. Further optimization for Web3 includes batch transactions and to minimize on-chain writes from front-end. Using decentralized storage like IPFS or interplanetary file system to minimize on-chain data storage. And finally, to use off-chain messaging solutions like Whisper for communication. Branching and testing a smart contract follows establishing a baseline for gas usage without optimizations. Then, we need to implement gas optimization techniques to it incrementally. We need to measure the improvement from the optimization and continuously repeat this process for maximum efficiency. Some gas optimization best practices are reviewing code regularly for gas optimization opportunities, thoroughly testing before deployment, documenting optimization techniques or strategies for future reference, and to continuously monitor gas usage and refine optimization. Now, let's take a look at case study of Uniswap v3. Uniswap is a platform which enables users to trade cryptocurrencies and is hosted on Ethereum blockchain and governed by UNI holders. The big update in v3 is called concentrated liquidity, which is liquidity that is allocated within a custom price range that you decide. This creates multiple fee tiers and it reduces gas fee. Though, it comes with its own risks like impermanent loss.